Hello, my name is Jackson Hogue,
My name is Varun Kochi.
and this is the biomechanics of an overhead handball hit. Theoretical data. So, in our physics class, we learned about moment arms, forces at an angle, and how that can affect motion. So, basically, an overhead handball hit consists of two moment arms created by the body right here. So, it's from the foot to the shoulder, and the second one is from the shoulder to the contact point of the ball. And the combination of these two moment arms actually create a greater velocity right here at the end of the second moment arm, which helps us put more force into the ball to produce the desired outcome. These two moment arms are basically rotated by two forces. So the first one is created by the leg, the leg that isn't being used as the pivot, stomping downwards to cause the rotation of the body. And the other one is controlled by the arm, back, and chest muscles to move your arm downwards to hit the ball. Now, as you can see, we actually have five data points. So we have our contact to shoulder length right here. So we have the contact point right here and the shoulder. The foot to the shoulder length. We have the arm to body angle right here. We have the dominant knee angle, and then we have the passive knee angle. Now, it was very difficult to come across any sort of data for this because since handball is such an unpopular sport, Um, so any data we did find, we also didn't trust because they weren't from reputable sources. So we decided using the physics concepts that we know of to produce our own optimum values, and here are the results right here.
Okay, these are the results of our data collection. We recorded this. We recorded 10 trials and put it in Canovia, and these are our data values for all the lengths and angles that we were supposed to record. In green is our average, and these are the average measurements of each value. Our difference is in yellow, and that's the differences between actual and theoretical values. And our standard deviation basically shows the how consistent our data values were. Analysis. Um, the first graph compares the average of our actual data to our optimal values. As you can see, our actual lengths and angles were larger than the optimal ones. This is something we would have to work on in the future. Our second graph is the standard deviation of trials. As you can see, our standard deviation usually ranges from 10 to 17, and this that's not very good, and it shows inconsistency.
Improvement plan.
What is the data telling us? Based on the standard deviation of the trials, the test subject is extremely inconsistent with their hits. The average values are greater than the ideal values, which means the subject is overextending and overcompensating, which is leading to adverse performance. Solution. The solution would be mindful of the actions your body is doing. Self-control and self-analysis is important to produce ideal values. You should record yourself as you practice, and it could help you zone in on your mistakes. In case of this subject, the solution is not to overcompensate and instead be mindful of proper form instead of rushing to hit the ball.
Acknowledgements of error. So in our trials, there was quite a few sources of error that could have occurred. So firstly, trying to find the data for an ideal hit was very hard to come by since it's an unpopular sport. And this meant we had to produce our own data using the physics concepts that we know. And from that, we could have produced some error. Also, each time we went to go hit the ball, there was not a very good method of keeping the ball in the same position between trials. So the way that we did this was having another person hit the ball and having the person that we were recording the data on receive the ball and hit it, which led to different scenarios on where the ball is being hit, which could lead to inconsistency in the data. Another error could also be from human error in Canovia. Anyways, this concludes our presentation. Thank you for listening.